Part D of this question asks, how many throws has a darts player got to take to be at least 99.999% sure he will hit the required section of the board? So how many throws to be 99.999% sure of hitting? So what we're looking for here is some number for R where the probability it will have been hit is at least 99.999%. And what we want is the smallest possible value of R. So we want it to be less than or equal to R in here. So we want the probability that X is less than or equal to R to be at least 99.999%. For example, if we found out that if we added up the probability of getting it on the first go, on the second go, on the third go, on the fourth go, on the fifth go, if we added up those 5 probabilities, we exceeded this value over here, then our answer would have been 5. So we're looking for some sort of mystery number over here. Now, because this is a less than or equal to probability, that means we've got to add up lots of probabilities. And when we're adding up lots of probabilities, what we've seen already is that actually it's easier to add them up when they are greater than something and they go on to infinity. So in this sort of question we actually switch it round to look at the opposite thing. Rather than less than or equal to, we actually look at greater than. And if we turn that round, we actually turn everything round. We turn that inequality round and we turn this around. Now turning this around is basically, instead of that percentage, it's that percentage taken away from 100%. If you take that away from 100%, you get 0.001%. So we have changed the original question with the less than or equal to sign into one with the greater than sign by switching everything around and looking at basically the opposite scenario. We've changed that around and we've taken that percentage away from 100. But rather than work in percentages, we really need to work in decimals. So as a decimal number, I need 2 more noughts in there, so it will be that as a decimal. Now, to work out the probability X is greater than R, we can actually use the result we've had already. In part C of the question, when we were looking for the probability that X was greater than 10, which we had here, probability X is greater than 10, that turned out to be 3/5 to the power of 10. So we had before, I'll just write that down then, from previously we had the probability X was greater than 10 was 3/5 to the power of 10. In this part of the question then, that 10 has become an R. So over here I just need to change that 10 to be an R. So the probability it's greater than R is going to be 3/5 to the power of R. That's just using a result that we had earlier on in this question. And I want to set that probability, if I just get my last bit of paper back, that has to be less than or equal to 0. And there was 4 zeros and a 1. So I've got to find out what value of R makes this probability less than that number there. Now again, it's something you may not have covered in core maths yet, something you may just have to take on trust for now. Before I do that question there, I'm just going to do a quick aside. If you had 2 to the power of something was 8, and you had to find out what the something was, you either get the answer because you know it's 3, or you get it by trial and error. You could use trial and error here, but I want to show you a new way that it will be dealt with in core maths later on. And you use the log button on your calculator, which is a button you may not have used before, the log button which is here. If you do log of the number that's on its own, and divide that by log of the other number that's over here, if we do that on the calculator, log 8 divided by log 2, I get the answer of 3. And that is this mystery number here. That's how you can find a power that is missing, by using logs. So if I had 2 to the power of something equals 8 and wanted to know what the something was, I'd do log of that divided by log of that. But the question I had up here was 3/5 to some unknown power. Now I'm going to change this to an equal sign to start with. There's that number there. And I'm going to use this little trick here first of all to find out what r must be. I did log of the number that's on its own divided by log of the number over here. And if you do that sum on a calculator, you can see this, log of 0.00001 divided by log of 3/5, which I just put in as 0.6. I get an answer of 22.537. So I've just found out that 3/5 to the power of 22.537 is 0.00001. The higher this number goes, the smaller this number gets. So if 22 makes it exactly this number, bearing in mind I've actually got to get it smaller than that number, I just need to go anything over this number here. And this is the number of trials the archer has to have. So it can only be whole number values. So what you do in this scenario is you always round that up to the next whole number. So if I round 22.5 up, I will get 23. So the answer to this question was 23. So if you're a bit puzzled and you want to see how that works, what you could do is just sort of check that. I'm going to do that in another video, because I just see I'm running out of time in this one. I'll do that in another video.